Okay, hello, and today we are going to look at the Ansys thermal transit example. Okay, so let's look at the question. So here's the question. There is a steel cylinder. Okay, this is a steel cylinder, and the diameter is 100 millimeter. Okay, so height is we know, and we know the initial temperature, and then this temperature, oil temperature, and then heat transfer coefficient they give us. So they ask the calculated temperature in the center of gravity and in the point at the edge of the cylinder by adding the time of 30 seconds and the 60 seconds. So here is the other features. Okay, so what we are thinking here, so let's imagine taking this part like that. Okay, so like that here. Okay, so let's start with an preferences. So thermal. Okay, so preferences, and then element time, add and delete, and so we can choose here the solid, and here is the plane 55, so it's okay. But we have cylinder, so we should choose the options, and then we should say axisymmetric. Okay, so close it. And the material properties and then temperature units, so I'm going to take the Celsius. Okay, so because these are the Celsius, so material models, thermal, so we should define these features. So here our conductivity, what was our conductivity is here, so 40. Okay, and then specific heat, so this is 480, and then density, so 7, 8, 20, and that's it. Okay, so that's it. So we have just one material, so I defined just one material, so keep going, and then we can continue with modeling. So we are like coming from like this order. Okay, so this is so easy, create, so areas, so rectangle by two corners, it's okay. So we have this diameter. Okay, so 100 like that, so I'm going to put here the 0.1, and here is the height is the 0.2. okay, you can also write like that. Okay, doesn't matter. So let's look at this one. Okay, so we take this part. So the important things here is that we should mashing. Okay, we should do this. So size controls, manual size and lines. So and so here's the 0.1 and is the 0.2, right? So I'm going to pick lines. No, I'm going to all lines, and I'm gonna say it. Okay, we can do it the size like maybe 0.005. Okay. It's okay. Okay. There's lots of mesh now. An area, so map, so we can choose it, or free, we can say it. So okay, that's it. So the other part we are going to solution. So analyze that new analysis. So this is transit. Look at here, we have 30 seconds and 60 seconds here. Okay, so it's okay, then full. Okay, so next part, solution controls, we gonna define here this time. So off, what is our time? Here's the 60 seconds. So this is 60 seconds. So this unit is the seconds, so time increment. So this is important, we should calculate it. Okay, so I'm going to write the calculator. So okay, look at here. So we have a formula, right, for the delta x. What is our formula? Let's write here. So delta x is equal actually the x square. Okay, so and times density times specificate and then over 2 times lambda, I mean the thermal conductivity here, so thermal conductivity. Okay. So let's look at here. So what is your smallest length? This is important, but I choose it 0.005. So I'm gonna take here the square of this one. This is so times density. This is density, and then the specificate this one. So that's so, and then over 40 times 2, so this is the 80, so that's it. So this is 1.173, right? Okay, so let's keep going to decide it. So this should be smaller. Your time step size should be smaller, this formula. Okay, what's my result? This one. So we can maybe pick 0.5 or 1. Okay, I'm going to choose here the 60 seconds again, and time increment step sizes. Okay, we can choose it 1 here. So write every end steps. Okay, so let's get off. That's it. Okay, here is the recomplicated is the half of the weight. Okay, so apply. This is important. Okay, so what we are seeing here, just like see the image here. So look at here. This is 50 seconds, right? So we know the second thermal, so it will be from the hotter part to the colder part. So you know this law. So it can convection from here to here, so surface to the oil. Okay, convection can happen from the surface to the oil. So I'm gonna just define like the convection. Okay, so on lines, and I'm picking the top and the right side. Okay, that's it. So field coefficient is here, this one. Look at here, and then the bulk temperature is the our bulk temperature is 50. Okay, here is 50, and that is okay. That's it. It finished. So initial condition. So define. So pick all, and then temperature, and then we're gonna say it's 8. That's it. Okay. So now write ls5. So you can just pick the one for these basic questions and then solve current ls. That's it. It's okay, and it's solving. Yeah, okay, here is our solution is ready. So the last set, or you can pick by like for example, if they are asking 30, you can say okay, read this one, and then I can see now my nodal solution here. Okay, let's look at here. So this is our answer. So look at here, look at our answer, and then the thermal flux is like okay, and okay, so maybe we can show the putting the graph. Okay, so time spherical preferences, so add, so nodal temperature, it's okay. So I'm picking this. Okay, and then I'm picking this one. This is the outside, and okay, so let's choose this one, and then just graph. Okay, this is our graph. Okay, this is the surface, you know, and this is the inside. So